When we talk about AC currents, we refer to currents that are a function of time and are often described by sinusoidal functions. For example, I max times cosine of omega t plus theta, which has this form here. And the maximum amplitude is given by I max. AC voltages are also a function of time and can also be expressed as sinusoidal functions. For example, a sine. Again, the maximum amplitude of the voltage, in this case here, would be denoted Vmax. Let's make an assumption that will simplify our analysis a lot. We will assume that there only exists one frequency omega in the whole circuit. The next thing that we need to do is to agree on one sinusoidal function. We could use sine or cosine or minus sine or minus cosine. Then we can express our AC currents and AC voltages as complex numbers. We want to write those complex numbers in polar form. Hence, we need the length or the amplitude and the phase of the complex number. The length of the phasor is defined to be the magnitude of the cosine or the sine that we had before divided by the square root of 2. And the same applies for the phasor length for voltages. In order to find the phase of our complex number, we need to agree on a sinusoidal function. Let's assume that we want to use sine. Then we can write the current as I max sine of omega t plus theta plus pi half. Hence, the phase of the current is theta plus pi half. Since we agreed to use sine as our sinusoidal function, the phase for the voltage is simply theta. Now we can combine the phase and the length of the complex number to write I as a phasor, namely capital I, e to the power of j, theta plus pi half. Expressing the voltage as a phasor yields V times e to the power of j theta. Because exponents sometimes tend to be hard to read, phasors can also be written as the phasor length, this symbol for the angle or the phase, and then the phase value. This change of notation allowed us to go from cosine and sinusoids to complex number descriptions. Later on we will see that solving AC circuits using phasor domain will be much easier than calculating with cosine or sines.